Now, for this recording, we're going to be focusing on question 4. It's mathematics level 3 NCV. This question 4, it's actually based on the algebra only, right? It's a supplementary paper from 2024. This was written back in February last year, 2024. All right. Now, there's 4 questions. 4.1, 4.2, all the way up to 4.4. So we're going to be answering all of these questions. Now, what I will do with the rest of the questions on this question paper, I'll answer every single question, but it's going to be in parts rather than answering them under or on one video. So I'll just do it in parts. I'll do one for question 1. I'll do another video for question 1, question 2, question 3, so on and so forth. But check the description box. I'll leave all the links for the questions that were answered for this question paper. Okay, so let's start with 4.1. They want us to solve for x and y if the first equation is this and the second equation is this one. We have to solve simultaneously. Okay, so we're gonna have this. Let me write here. So we're gonna have this 4.1. We have the first equation being this 3y minus 2x equal to 0. We're gonna label this as equation 1, and then we have a x squared minus y squared plus 2x minus y equal to 1. Second equation. All right, so what I told you in class, guys, was that you need to pick the equation where one of the variables has a coefficient of 1, right? So if you take a look at equation 1, we have this variable y having a coefficient of 3. We also have the second variable x having a coefficient of 2. So what I said in class was you need to choose the equation where at least one of the two variables has a coefficient of 1. So the first equation, we don't get that, right? We don't get that. Now, let's take a look at the second equation. The second equation, I see that y actually does have a coefficient of 1, all right? Actually does have a coefficient of 1. But choosing the second equation, it's going to be a little bit tricky now, because the aim of generating or creating a third equation is actually to have the equation as one variable equal to some variable. Let me show you something. Let me not use this slide to write. Instead, let's take equation 2 and generate the third equation by making y the subject of the formula. So we're going to say x squared minus y squared plus 2x minus 1 equal to positive y. So what I did, I took the y over here and the minus 1 to the left hand side. So I just swapped the positions for the y and the 1. Now, the trick is that once you have y as being the subject of the formula, I'm expecting the other side to have only one variable. So if I made y the subject, I'm expecting to see only x variables on the other side, which is not the case. We have a y squared on the other side, right? So that's the trick with picking equation number 2. So what should actually happen? We should be taking equation 1. Yes, it's not an ideal equation to deal with because we're going to end up with a fraction, right? But we have to take equation 1. We have no other choice but to, just to make our lives easier. Let me say that. Now we're going to take the first equation, 3y minus 2x equal to 0, and make, it's up to you whether you're going to make y or x the subject of the formula. But in this case, let us make x the subject of the formula. So I'm going to take this over to the other side. I'm left with a minus 3x I mean 3, 3 minus 2x. On the other side, I'm going to have a minus 3y. Then I'm going to divide by minus 2 on both sides. I now have x as a subject of the formula. So this is going to be 3 over 2y. This is my equation 3. This is what I was talking about. If you have x as a subject of the formula, on the other side, you should only have y as the only variable, right? And we did not see that with equation number 2. All right, so this is equation 3. This is equation 3. So we're going to take equation 3, substitute equation 3 into equation number 2. Into equation number 2. So let's substitute the x. So x squared, this is the second equation, plus 2x minus y equal to 1. So where there's x, I'm going to substitute the 3 over 2y squared minus y squared plus 2, open bracket, 3 over 2y minus y equal to 1. I'm going to have a 9 over 4y squared minus y squared, and then this 2 cancels this 2 because I'm taking this 2 and multiplying this fraction. I'm going to have a 3y minus y equal to 1. Like terms for the first two terms. So this is 9 over 4, subtract 1. I'm left with a 5 over 4y squared, and then a 3y minus y. So it's basically 3 minus 1. That is 2y. And then let's transpose the 1 over to the left hand side because we have a quadratic equation on our hands. Now, at this point, you can either use the quadratic equation, or you can complete the square, or you can use the factoring method. Okay, you have 3 choices here. So I think the easiest bet would be to go with the quadratic equation. So what I'll do, I'm going to use the factoring method to simplify this equation. But first, I'll have to eliminate the fraction. So I'm going to take the LCM and multiply each and every term over this equation, right? So the LCM is 4. The 4 cancels the 4. I'm left with a 5y squared plus 4 times 2, that's 8y. 4 times 1, that's minus 4, equal to 0. Equal to 0. All right. Not an easy one. Not an easy one. Not an easy one. Not an easy one. But here we're going to have a 5y, a y, and then we're going to have maybe 2. Yeah, 2 and 2. Yes, plus 5. I mean plus 2 minus 2 here. So these are the factors for this equation. So whether you use the quadratic equation or you complete the square, you should have the same answers as me, which is y equal to a 2 over 5 or y equal to minus 2. So these are the solutions to this equation for the y values. Now let's get the x values, meaning that I'm going to take the y values and substitute into equation 3. We're going to substitute y into equation number 3. So x is equal to 3 over 2, 2 over 5. So I'm substituting the first y value, which is 2 over 5. Multiplying this gives me a 3 over 5. A 3 over 5. And then for the other x value, where we are substituting y as minus 2, we should have an x that is minus 3. So this is x, this is another x, this is y, and another y. So this is how we would go about solving this equation. Alright, there's something that I'm not feeling comfortable about, more especially when it comes to that second equation. Okay, no, the answer, I have confidence in this answer. It's just there's something bothering me. Let me just erase here. Let me just erase this part. Okay. Say we decide to take the second equation. Say, okay, I'm not going to solve the whole thing. We are done with 4.1. I just want to see something. If we take the second equation and try to generate the third one, we're going to have this plus 2x minus 1 equal to y, as I've showed you. And then this is equation 3. Substitute equation 3 into the first equation. So it's going to be a 3y, open bracket, you're going to substitute this entire thing, x squared minus y squared plus 2x. Okay, let's continue. Minus 1 minus 2x equal to 0. We multiply, we have a 3x squared minus 3y squared plus 6x minus 3. Oh, okay. Minus 3 minus 2x equal to 0. Okay. Yeah, no, this doesn't help. This doesn't help, because if I continue like this, minus 3y squared, this 6 and this 2 gives me a positive 4x minus 3 equal to 0. I end up with two variables in this equation. You see the problem now? Yeah, no, justified. It's justified. Avoid using the second equation, because if you take it like this, it's going to give you problems along the way. It's going to give you problems. So the most effective or efficient way of solving this one would be to take the first equation and solve either for y or x as the third equation. So 4.2, we are solving for x. We are given 4.2.1 x 3x minus 4 equal to 4. So in this case, they are telling you to solve for x. However, they don't specify the method of simplification. So this is up to you on what you're gonna do with this equation. So it's a quadratic equation. So after removing the bracket, we're gonna have a 3x squared minus 4x equal to 4. Right? Hence I'm saying there's three ways of simplifying. It's a quadratic equation, this one, right? So they don't specify the method, so you get to decide. You know, I'm feeling like using the completion of the square for this one. Let's go ahead and do that one. So it's it's gonna be an x squared minus 4 over 3x minus 4 over 3 equal to 0. So remember, when you complete the square, you need to make sure that the a value is what? Is positive 1. A value, what do I mean? A quadratic equation in standard form is like this. The a value, meaning the coefficient of the x squared, must always be a positive 1. That's what I was saying. Now b, we multiply it by a half and square the answer. So what is b? That's minus 4 over 3 multiplied by a half squared equal to, we multiply, we're gonna have a minus 4 over 6 squared, we're gonna have a 16 over 36. Wait a minute. Okay, wait a minute. Okay, so 4 over 3 times a half, that should be a 2 over 3. Yeah, because 2 goes into 4 twice, right? So 4 over 2, that's 2. Hence I'm having a 2 here. But just punch the when you punch this on a calculator, you should get a minus 2 over 3. When simplified, it's going to be a positive 4 over 9. Okay, then we proceed over here. X squared, and then it's gonna be a plus 4 over 9 minus 4 over 3 minus 4 over 9 equal to 0, equals to 0. All right, then we take the first three terms and factorize that. We're gonna have a perfect square as our factors, so it's gonna be an x minus 2 over 3 squared. So factorizing this is just taking x and placing it here as the first term in the bracket, and then just before squaring the value, just before squaring, you're gonna place it here, then say square, and then you square the whole thing, and then we have a 4 over 3 minus a 4 over 9, 4 over 9, that's minus 16 over 9 equal to 0. All right, then we're gonna have an x minus 2 over 3 squared equal to 16 over 9. You take the square root on both sides, you now have an x minus 2 over 3 plus minus 4 over 3. You transpose the x, plus minus 4 over 3 plus 2 over 3. So first answer, it's going to be the positive 4 over 3 plus 2 over 3, or x is equal to a minus 4 over 3 and a plus 2 over 3. All right, so the first x is going to be 6 over 3. 6 over 3, so the answer should be 2. Yes, it should be 2. And then for this one, x is going to be equal to minus 2 over 3. Minus 2 over 3. So the x value is going to be x equal to minus 2 over 3. So we have two x values, this one and this one. All right, I could have used the factoring method, but just for this video, I decided to go with the completion of the square. Of course, you can also opt to the function or to opt to the option of using the quadratic formula. That's still fine. Okay, that's 4.2.1, 4.2.2, and then we have this x minus 2 minus x minus 2 over 2 equal to 0. Okay, so this is an equation with a fraction. Equation with a fraction. All right, so an equation with, when it comes to an equation with a fraction, we actually need to simplify for the fractions. How do we do that? We actually start off by finding the LCD. The LCD in this instance is going to be the 2x minus 2. Then we take the LCD and multiply each and every term on that equation. So we have the 2 over x minus 2. We multiply that by 2x minus 2 minus x minus 2 over 2. And then we multiply this by 2x minus 2, equate this to 0, and multiply by the LCD as well, 2x minus 2, x minus 2. All right, so this gets cancelled by that. 2 times 2, that's 4. This gets cancelled by this, not equal to minus, so this gets cancelled by this. The x minus 2, this one will get multiplied by this x minus 2, equal to 0. Anything multiplied by 0, it's 0. So it's going to be 4 minus, we FOIL, we have x squared minus 4x plus 4 equal to 0. Then we simplify, we have a 4 minus x squared plus 4x minus 4 equal to 0, then I can see that this 4 and this minus 4 are like terms, but they're gonna cancel out when simplified, when added together, I mean, plus 4x equal to 0. So then we take out a common factor here, which is x. I'm now going to be left with a minus x plus 4 equal to 0. So the first root or first answer is going to be x equal to 0, or minus x plus 4 equal to 0. That's minus x minus 4. X is equal to a positive 4. So this is my solution. So these are my solutions. So that's 4 marks for 4.2.2. Now for this 4.3. So this is a quadratic inequality equation. The 6x squared greater or equal to 9x will be dealt with like this. First of all, you need to standardize the equation. Bring everything over to the left hand side. Minus 9x greater or equal to 0. Okay, greater or equal to 0. Now at this point, you now have the equation in standard form. The next step would be to calculate the critical values. We now remove the inequality sign with an equal sign. There's a common factor, which is 3x. Then inside the bracket, I'm going to be left with a 2x minus 3 this side equal to 0. So the 3x equal to 0, or the 2x minus 3 equal to 0, gives me as x equal to 0 this side, and then x that is equal to 3 over 2 this side. I have two roots, 0 and 3 over 2. Okay, so using the graphical method, since the a value is bigger than 0, meaning that it's positive, it's gonna be a smiling graph like this. And then the x equal to 0, we always start with the smallest value. In this case, the critical value that is the smallest between the two, it's x equal to 0, and another x that is 3 over 2, which is bigger than 0, by the way. Okay, now after plotting your critical solutions on the plot, the next step would be to check your inequality sign. You see that the inequality sign says what? Greater than or equal to 0. If that's the case on the graph, you're gonna have to draw solid circles at your critical points, right? In this case, what is important, guys, is the sketch itself and the solution and the final solution now, since the inequality sign is bigger or equal to 0, so it means that it's above the x-axis. If it was less than or equal to, our solutions would lie below the x-axis. If your answer says greater or equal to, bigger or equal to, look for your solution above the x-axis. If it's less than or equal to, look for your solution below. Now, since the inequality sign is pointing to the right, it's bigger than, our solutions are gonna be facing this direction. They're gonna be to the left of 0 and to the right of the 3 over 2. So the first solution is going to be x less than or equal to 0. When I'm pointing to the left, I'm facing the negative side, so my x will be less than or equal to 0 in this case, or x greater or equal to a 3 over 2, to the right of the 3 over 2. Anything to the right of 3 over 2 is bigger than the 3 over 2. Hence, I'm having this solution and this solution. But now, they want us to represent our solution in set builder notation. Now, this is the set builder notation. X the x should be less than or equal to 0, or x should be greater or equal to a 3 over 2, where x is element of real number. So this is the set builder notation. Now for the last solution, for the last question, the 4.4, for the 4.4 we have an algebraic expression on this one. Okay, so we have to prove that the left hand side is equal to the right hand side. We have to prove that this is equal to this. Let's take the left hand side and simplify it. We have an x minus y raised to exponent 2 over 2 divided by 2 over 3 y minus x raised to exponent minus 2. So this is the left hand side. This is 3, by the way. Let me just quickly fix this. It's 3. Okay, so I have two fractions dividing each other, so we need to do what? Tip and times. Let me start with that first. Y squared over should I? You know what? Let's do it anyway. Let's just do it. 2 multiplied by 3. Don't worry about the negative sign for now. Y minus x raised to exponent minus 2 over 2. So what I basically did, I changed the division sign to a multiplication sign and flipped the second fraction, right? So that's tip and times. That's tip and times. We are tipping and then timesing. Okay, now we have a situation on our hands. It's this entire thing. A lot is going on here. Now the first thing any identifier is the exponent. It's negative. We have to solve for the negative exponent. Another thing that is concerning is what's inside the bracket. Y minus x, right? Y minus x. This needs to be fixed so that you start with the x and then you follow it up with the y. The reason why, by convention, right? By convention, most of our variables we at least try to write them in alphabetical order, right? If you have an a plus b, and then on the other side you have a b plus a, okay? So this, well, there's nothing wrong writing your expression like this, or even writing it like this, but just as a rule of thumb, right? Always start with the, or write your write your variables in alphabetical order. So you have a plus b, this is good. You have a plus b. You just rearrange the above, right? So in this case, instead of having a plus between the two variables, I have a negative sign between them. This is where we'll have to apply the sign change rule to achieve the above idea, to implement the above idea. There's a reason for that. But first, before we deal with what's inside the bracket, let's start with the negative exponent. Let's deal with the negative exponent first. Multiplied by 3 over 2. Now, I have a expression with a negative exponent. In order to get this to be a positive exponent, I would do this. This will move from this numerator part to the denominator part of the fraction. It's now going to be a y minus x raised to exponent 2. Okay, if it was at the denominator and you had to change a negative sign for it, you were going to take it to the numerator. Equal to x minus y squared over 2 multiplied by 3 over 2. Sign change rule, it's minus x minus y, like this, minus y, like this, equal to, we continue, x minus y squared over 2 multiplied by 3 over 2. Now, we know that anything squared gives us a positive, right? It gives us a positive. So, in this case, I have this bracket. Inside this bracket, I have a negative value. I have a negative expression, and the bracket is squared. Anything squared gives me a positive value. A minus 1 squared gives me a positive 1. A minus 3 squared gives me a positive 9. This is what I'm trying to say. So simplifying this would give me a x minus y squared, right? So the whole point of me trying to rearrange the order of our variables was me trying to simplify this to this was me trying to simplify, or let me just say, I saw that if I apply the sign change rule, this bracket will be exactly the same as that bracket, right? Because eventually they'll have to cancel. So this 2 times 2, that gives us a 4, and then 3 is our numerator. That's what remains after the cancellation. So 4.4 concludes our discussion for question 4. Have any questions? Leave them in the comment section of this video. Now we enjoy this recording. Leave a thumbs up. Share it with your colleagues, not colleagues but classmates, and anyone whom you think will find this video useful. So in the description box, I'll also leave links for other questions that I've answered for this question paper. So for now, guys, catch you on the next one.